Hey, Chloe. Didn't expect to see you here.
Eh? Hi, Silas. By the way, that chemistry class was confusing, right?
That chemistry class was wild. Catalysts increase activation energy, but somehow speed up reactions?
Right? And why does the forward reaction go faster than the reverse one? So weird. Let's ask the teacher.
Sure. Mrs. Rosie, Mr. Dymel. We're confused about catalysts.
Yeah, like, do they increase activation energy?
Oh, you're curious, huh?
All right, let us explain it to you.
Come on, make sure you pay attention to our explanation.
That's right, let's go. Many students often misunderstand the concept of catalysts in chemical reactions. One common misconception is that catalysts speed up reactions by increasing the activation energy. In this incorrect understanding, students may think that catalysts provide more energy to the reactant molecules, thus increasing the activation energy and making the reaction faster. Where, first, activation energy is considered as additional energy. Students may think that catalysts increase the energy of the molecules so that they have more energy to overcome the energy barrier. Second, focus on molecular energy, not the reaction pathway. Students misunderstand that catalysts change the reaction pathway, not add energy to the molecules. Third, misunderstanding of the potential energy diagram. Students who do not understand the potential energy graph may associate the acceleration of the reaction with an increase in activation energy. Here is a visual representation illustrating the misconception that a catalyst increases the activation energy. In this diagram, the reaction with a catalyst is shown with a higher activation energy peak compared to the reaction without a catalyst, which reflects the incorrect idea. Both curves have the same final energy level, which is part of the misconception. A catalyst does not increase the activation energy. Instead, it lowers the activation energy by providing an alternative pathway for the chemical reaction that is more easily accessible to the reactant molecules. With lower activation energy, more reactant molecules have enough energy to react under certain conditions, such as at the same temperature. Therefore, a catalyst speeds up the reaction by lowering the energy barrier, not by adding extra energy to the molecules. A catalyst speeds up a reaction in the following ways. First, lowers the activation energy. A catalyst creates an alternative reaction pathway that requires less energy to start. Second, does not change the total energy of the reaction. A catalyst does not alter the amount of energy released or absorbed during the reaction. The total energy of the reaction remains the same, meaning the catalyst does not affect the enthalpy, delta H. Third, affects the rate of both the forward and reverse reactions equally. A catalyst speeds up both the forward and reverse reactions equally without affecting the position of the equilibrium. Activation energy is the energy barrier that must be overcome for a reaction to occur. Without this energy, molecules cannot interact effectively. How does a catalyst work? A catalyst speeds up the reaction rate by lowering the activation energy. It achieves this by providing an alternative reaction pathway. The catalyst is not altered or consumed during the reaction, so it can be used repeatedly. Effect on forward and reverse reactions. First, a catalyst affects both the forward and reverse reactions equally. This means that it speeds up both directions of the reaction without changing the equilibrium position. Second, the position of equilibrium is only influenced by factors such as temperature and pressure in line with Le Chatelier's principle. For more details, feel free to check out this awesome YouTube video.
A catalyst is a substance that accelerates the rate of a chemical reaction without undergoing permanent changes. Catalysts work by providing an alternative reaction pathway with lower activation energy compared to the pathway without a catalyst. Activation energy is the minimum energy required for a reaction to occur. By lowering the activation energy, more reactant molecules have enough energy to react, thereby increasing the reaction rate. In the diagram above, the blue line represents the reaction pathway without a catalyst, showing a higher activation energy peak. The red line represents the reaction pathway with a catalyst, where the activation energy peak is lower. This reduction in activation energy allows more reactant molecules to reach the energy required to react, thereby increasing the reaction rate. Silas and Chloe thought that a catalyst increases the activation energy so that the reaction proceeds faster. That was a misconception. The correct concept is a catalyst does not increase activation energy, it lowers it. By lowering the activation energy, the catalyst makes it easier for reactants to transition to the product state, thus speeding up the reaction. The next is, catalysts increase activation energy, providing more energy for the reaction. That was a misconception. The correct concept is, catalysts do not add energy to the reaction system. Instead, they provide an alternative pathway with a lower activation energy. The catalyst remains unchanged at the end of the reaction, meaning it can be reused multiple times. For more details, feel free to check out this awesome YouTube video.
In conclusion, the two misconceptions about catalysts highlight a common misunderstanding regarding their role in chemical reactions. First, a catalyst does not increase activation energy, but rather lowers it, facilitating the reaction's progression by making the transition to the product state easier.
Second, catalysts do not supply additional energy to the reaction system. Instead, they offer an alternative pathway with reduced activation energy. Importantly, catalysts remain unchanged after the reaction and can be reused, making them efficient tools in chemical processes.
Thanks for watching and see ya!
Remember, chemistry is fun and easy.